Okay, so this reaction needs knowledge of group 1 metals. And it wants us first of all to predict what you would see when a small piece of rubidium is placed in a large volume of water. So if you think about what you saw when we've done lithium and sodium and potassium in class, then we would see the metal floating on the surface. It would be moving around. It would be fizzing as it produces a gas. We probably, because remember with potassium we get a flame, so a flame would be produced, and the metal would disappear by the end of the reaction. 3 marks, any 3 of those points is going to get you the mark. Why is rubidium more reactive? And if you remember what's going on here in reactivity is that the outer electron that it's trying to lose is further away, and therefore it's more shielding and less attractive force. We're looking for something that reflects that. So this one talks about metallic bonds, that's nonsense. Rubidium is softer, that's nonsense. The outer electron of rubidium is further from the nucleus than it is potassium, that's looking positive. Rubidium has more, no, so it's option C is the only one that makes sense. Carrying on, here we've got a calculation. What I've done to help myself is I've just copied the equation from above and put it here to give me a reference point. So I'm told there are 8.5 grams of rubidium, and it wants me to calculate the concentration of the rubidium hydroxide, which is this. This is a slightly different question, and we've got to think on our feet a little bit here. So first job, I'm going to convert the 8.5 grams into moles. So according to my triangle, moles is the mass divided by the MR. So the mass is 8.5 and the MR, we're told here, is 85. So when you do that on your calculator, I'm just going to do it on mine. 8.5 divided by 85 is 0.1. So I now know I've got 0.1. The next thing to just check is the ratio. So I've got 2 moles of this, and I've got 2 moles of rubidium hydroxide. So this means I'm going to have 0.1 moles of rubidium hydroxide. And what I now need to do is convert that into a mass, because I've got to get my answer into grams. So step number 3, because that was step number 2, is to work out the mass. So the mass is going to equal, according to the triangle, the MR times moles. The MR for rubidium hydroxide is 102, and I'm going to times that by 0.1. So times by 102, and that's giving me 10.2 grams. So I now know I've got 10.2 grams of rubidium. So I can now find the concentration. Now remember, concentration is amount, concentration, and volume. So it's a chicken vindaloo. And what I'm trying to find here, it says, is calculate the concentration. So the concentration is the amount divided by volume. The amount is 10.2 divided by the volume is 2.5, and that's already in decimeters cubed, so I'm okay just to use that. Divided by 2.5, and that's giving me 4.08, and that's grams per decimeter cubed. And that's my final answer in that question. That's a tough one. 4 steps, because that's the final step there. But if you work your way through using the knowledge and the equations we have, hopefully you have managed to get there. Okay, let's make this equation work for us. So we have got a reaction between rubidium hydroxide and ammonium carbonate. So let's put rubidium hydroxide, which the formula is up above, and we're adding to it ammonium carbonate. And it tells us that forms rubidium carbonate, so RbCO3 with ammonia with one other product, which is going to be water, because we need to have more hydrogens and oxygens to make this work. Right, over here, let's change colour. Rubidium on this side, then we've got oxygens, then we've got hydrogens, and then we have got carbons. Put them in the same order over here. So I've got rubidium, oxygen, hydrogen, and carbon, and I've actually missed off the nitrogen, so let's stick nitrogen in as well. Okay, so rubidium's is 1, oxygen's is 3, and that becomes 4, hydrogen's is 8, and then there's one over there which becomes 9, carbon's is 1, and nitrogen's is 2. On this side of the equation, I've got 2 rubidiums, I've got 3, 4 oxygens, I've got 3, 4, 5 hydrogens, 1 carbon, and 1 nitrogen. So first job is let's get the rubidiums to balance. If I put a big 2 in front of here, I'm going to get 2 rubidiums, which is fine. I then got 3, 4, 5 oxygens, and I'm going to get 8, 9, 10 hydrogens. So can I make this side balance? Let's get the nitrogens to work first. So I need 2 nitrogens there. So my nitrogens are okay. That gives me 6, 7, 8 of those here. So I've got a few more bits to sort out. Let's see if I can sort out my hydrogens. So I need to, if I put a 2 there, that gives me 6, and 4 more is 10, so that works okay. And then I'm going to have 3, 4, 5, so we've got a balanced equation. Marks wise, what we're going to get here is 1 mark for the formula being in there correctly, and then 1 mark for this equation being balanced correctly.